Alright, this is the video on how to answer the ramps and inclines problems. We answered most of it in class, but just in case you didn't catch how to answer a particular problem, watch this video. Okay, let us start by answering this number 6 because it's a little bit easier because there's a diagram given to you and it's very specific what forces you need to calculate. Okay, so number 6, in each of the following diagrams, a 100 kilogram box is sliding down a frictional surface at a constant speed of 0.2 meters per second. The incline is different in each situation. Analyze each diagram and fill in the blanks. Okay, so like what we discussed in class, when you have an object that is an incline, the first thing that you should do is to choose which is your x-axis and which is your y-axis. So we are always choosing that along the incline is our x-axis, and then perpendicular to the incline would be our y-axis. And with that, we will see that the normal force is the same as the y-axis, and the frictional force is on the x-axis. The Fg is in between the x and the y-axis. Since force is a vector, F gravity that is here, we can separate it into two components. This component and this component. And then based from our trigonometry, we discussed this in class, that every time that you have the component along the x-axis, this should be equivalent to Fg sine of theta. And this one is Fg cosine of theta. Okay, if I'm going to redraw it so that my free body diagram, we're calling this one a pseudo free body diagram, so that it's a little bit clear. The other lines are gone. We know that this is your force, normal force, this is your friction force, and this is Fg cosine of theta. This is Fg sine of theta. Okay, so now let us calculate each of the blanks that is asked here. We can easily calculate our force of gravity, our weight, because we know that it is equivalent to mass times acceleration due to gravity. And the mass given is 100 kilograms multiplied by the acceleration due to gravity, which is 9.8 meters per second squared. If we multiply this this should be equivalent to 980 newtons. Okay, next thing, the normal force. If you look at your normal force, looking at your pseudo free body diagram, your normal force is pointing at this direction. It is moving at a constant speed. If it's moving at a constant speed based from this one, this is equivalent to Fg cosine theta. So our normal force is equivalent to Fg cosine theta. And then our Fg, we calculated Fg earlier, that is 980 newtons, multiplied by your cosine theta. Then your answer should be equivalent to 849 newtons. For your force of friction, you will see here that your force of friction is equivalent to Fg sine theta because it's moving at a constant velocity, right? This should be equivalent to this one. So we can multiply Fg with sine theta. Fg is 980. Sine of 30 should be equivalent to 490 newtons. Okay, and that's it. It will be exactly the same process. The only difference is we're changing the theta to 30. By the way, this one is 980 cosine 30. We're changing the angle 30 to 45. It should be exactly the same process. If we follow exactly the same process, your force of gravity should be 980 newtons. Your normal force should be around 693, and your force of friction should be equivalent to 693 newtons. All right, now number one. A 5 kilogram mass is held at rest on a frictionless 30-degree incline by a force F. What is the magnitude of F? Okay, so let us draw first let us draw our diagram. We know that it is an incline that is 18 degrees, and then there is a mass, and then it is held at rest. Oh, sorry, it should be 30 degrees. It's not 80 degrees, 18 degrees. Um, there is a mass that is at rest, and it is held by the force F. We know that the force should be going this direction because if there is no force, the tendency of this one is going downward. It is frictionless, there is no friction. But the reason why it's staying at rest is because of the force that is going that direction. Okay? And then we know that there is Fg, and then there is normal force. Okay, actually, I will be changing the Fg to mg already because we know that Fg is equivalent to mg. Okay. All right. So choose your axis. This will be my x-axis and this will be my y-axis. Let me change that one. Maybe this one is your x-axis and this one is your y-axis. Okay. So when we have that, we know that your mg can be separated into two components. And along the x-axis, that is mg sine of your theta. And then this one is mg cosine of theta. Okay, drawing our pseudo-free body diagram. F mg sine of theta. This is Fn. And this is mg cosine of theta. All right. So the question is, what is the magnitude of your F? This one. What is this one? If it's held at rest, you know that the net force is 0. If the net force is 0, Fn should be equivalent to mg cosine theta. Then your force should be equivalent to mg sine of theta. Okay. So for letter A, our F is equivalent to mg sine of theta, which is equivalent to 5 kilograms. Our G is 9.8 meters per second squared. And then sine of our angle, which is 30. If you calculate this, you should have 24.5 newtons. Okay, B. In general, the greater the angle of the ramp, the greater or lesser the force of gravity along the incline. Okay, force of gravity along the incline. The force of gravity along the incline is this one, which is directly proportional to your force. The same, exactly the same as your force. So, just thinking about it, we know that if you increase the incline, the force of gravity along the incline, or the force that you need to support the mass to be in place, should be getting higher. So it should be greater. Another way to do that one, another way to justify your answer, you can plug in a new value of this sign. Let's say you can put mg sine of, like, I don't know, maybe 60. You will see that the value will be higher. So it means that as you are making the theta higher, the force of gravity along the incline is getting higher as well. For letter C, in general, the greater the angle of the ramp, the greater or lesser the normal force. Justify your answer. Okay, based on your pseudo-free body diagram, you will know that your Fn is directly proportional to or equivalent to mg cosine of theta. Okay, if you get several values of the theta, Let's say you make it like mg cosine of say 20, and then mg cosine of let's say 40. You will see that your fn will be, okay, let me just calculate that one. 5 times 9.8 times cosine of 20. This should be 46.04 newtons. And then the other one should be um, 37.54 newtons. So you will see what happened when you increase, when you increase the angle, your normal force is decreasing or getting lesser. Decreasing. Oops. Yeah. Oh well. I don't know why it's not writing down. Okay, well, it's decreasing or getting less. Okay. Next number, number 2. A 10-kilogram box slides down a frictionless 18-degree ramp. Find the acceleration of the box. Okay, let us draw again our incline. That is 18 degree from the horizontal. There is a 10-kilogram box and it's frictionless, and you know that if it's frictionless, the tendency of this one is to go down, so it's accelerating downward, and there's no other force present except for the force of gravity and your Fn. Okay, again, I'm always forgetting. Let us change our Fg to mg. Okay, then choose your x and y axis. We're gonna choose that this is our x-axis and this is our y-axis. Okay, so we will know here that you have Fn going this direction, and then your force of gravity can be separated into two components. Along the x-axis, that will be mg cosine of sine of theta, and then along the y-axis, that is mg cosine of theta. We're drawing our pseudo-free body diagram. Okay, now if you're gonna be drawing our pseudo-free body diagram right here. Oops. It's gone. Okay, let me draw it again. Okay, so if I'm gonna draw our pseudo-free body diagram, it should be, it looks like this one. Okay, and then I have mg sine theta here and mg cosine theta right here. And then for letter A, we need to find the acceleration. Based on Newton's second law of equation, we know that acceleration is equivalent to net force over m. And if you look at our pseudo-free body diagram right here, since it's only accelerating this direction, we know that it's not accelerating up or accelerating down. So if it's not accelerating up or accelerating down, we know that Fn is equivalent to mg cosine theta. So this, the net force along this axis is 0. So what is the only force remaining? It's only this one. So this is our net force. And this is mg sine of theta divided by m. Okay, so if you look at this one, we can see that m can be cancelled, and a is equivalent to g sine theta. And you know, our g is 9.8 meters per second squared, and then our sine of theta, our theta is 18. If you calculate this one, this should be equivalent to around 3.03 meters per second squared. Okay, so we will see here also, we will notice here that in this equation, mass doesn't matter. The acceleration doesn't depend on mass. It only depends on the incline, on the angle. Okay, so if we're going to answer letter B, if the incline is not frictionless, is the acceleration of the block going to increase or decrease? Justify your answer. Okay, but just thinking logically, we know that the friction is opposing the motion. Okay, so if you want to calculate um, for the acceleration, and let's say for example there is a friction, it will be exactly the same thing except for the cosine theta. This is mg sine theta, except that there is a friction that will be opposing it. So for your net force would be equivalent to this one, mg sine theta, minus your force of friction, let me label this properly, divided by m. So you will see that from this one, your A will be decreasing. It will decrease. Okay. Number three is exactly the same. A block slide down a frictionless inclined plane that makes 30-degree angle with the horizontal. We just change the angle. And the difference between number 2 and number 3 is that on number 3, I didn't give you any mass. There is no mass. Right? There's no mass. But based from this one, we see that mass really doesn't matter. Right? Because when we solve for the net force, that is equivalent to net force over m. It's exactly the same thing. So this is mg sine theta for our net force. And then m, you will see that your m cancels. So your A is equivalent to g sine of theta. So we can calculate our A, 9.8 meters per second squared, multiplied by sine of 30. Then our A should be equivalent to 4.9 meters per second squared. Okay, next for letter B, is the acceleration going to increase or decrease as you increase the angle? Okay, thinking logically, you know that the acceleration will increase if angle will your acceleration will increase. Let me rewrite it. Acceleration is increasing as your angle is increasing. And to prove that one, you can make some calculation here. That let's say for example, instead of 30, you have an angle of, let's say, increase 40. So from 30 to 40, what will happen? 9.8 times sine of 40. The answer would, 9.8 sine of 30, sine of 40, that is around 6.30 meters per second squared. So see what happened to the acceleration. It increases also. Okay, so that's number 3. Number 4, it's similar. What's the only difference? Well, actually, it's not really similar. In here, we have 5 kilogram block slides down an inclined plane that makes 40-degree angle with the horizontal. If the coefficient of kinetic friction is 0.3, so your coefficient of kinetic friction is 0.3, find the acceleration of the block. So when you have that one, if you're given that one, it means that you don't have a frictionless surface. There is a friction that is acting on your mass. So let us draw Our diagram, there's 40-degree angle, there is a mass going up, sorry, at an incline, and there is mg, there is Fn, and there's a friction. So a tendency of this one, the friction should be going to the opposite direction. And then hopefully at this point you already know that this will be equivalent to mg cosine of theta, and this one is equivalent to mg sine of theta. Okay, we're drawing my pseudo free body diagram. Fn, Ff, this one is mg sine of theta, this one is mg cosine of theta. We want to calculate the acceleration. Same equation. Net force is equivalent to m. But if you look at this one, it's accelerating downward. So it means our total net force is not zero here, but it's not accelerating up and down. So the total net force for vertical is zero. So this will cancel. This is exactly the same. Okay, and then for our force of friction, this one, you have a force of friction going this direction and mg sine theta going this direction. They are not equal, because the reason why they're not equal, because they said it's accelerating downward. So your net force would be equivalent to the total of this, but since they are moving in opposite directions, we are subtracting them. So that will be mg sine of theta minus your mu, or well, let's just put it as ff first, minus your ff divided by m. Okay, now for your force of friction, we know that our force of friction is equivalent to mu times Fn, right? And then we know that our Fn, based from this one, since it's not accelerating up and down, our Fn should be equivalent to this one. So that will be mg cosine of theta. And let's just plug this in here. So A is mg sine of theta minus my mu mg cosine of theta divided by m. Okay, and we can cancel m here because just your algebra. That is g sine theta minus mu g cosine theta. I just put out m divided by m. You will see that m cancels. So your A should be equivalent to g sine of theta minus mu g cosine of theta. Plug in the values. This is 9.8 meters per second squared multiplied by sine of 40 minus the mu given to us is 0.3. And again, g is 9.8 multiplied by cosine of 40. You should get a value of 4.05 meters per second squared. Alright. Next, number 5, and the last number. A frictionless inclined plane of length 20 meters has a maximum vertical height of 5 meters. If an object of mass 2 kg is placed on the plane, which of the following best approximate the net force it feels? Okay, if we're going to draw it again, here you know that your incline is 20 meters, right? And they said your vertical height is 5 meters. Okay, so the first thing that you can do right here is to calculate your angle. And if we know this one, which is our hypotenuse, And this one is our opposite. We know that we can use our sine to calculate for the angle. If you're getting the angle, you're getting the inverse of sine. Inverse of sine in here because we have opposite, which is 5, divided by the hypotenuse, which is 20. And this should be approximately 14.48 degrees. So that is your angle. And then after that, you can just follow the same step that we did before. Okay, so we have the angle of 14.48. We have a mass 2 kilogram, and our 2 kilogram has mg, force of gravity. There is Fn, and it's frictionless. That's it. And we know that this is the perpendicular component, which is mg cosine of theta, and this is the parallel component, which is mg sine of theta. And then if I'm going to redraw my pseudo-free body diagram, this is Fn, this is mg cosine of theta, this is mg sine of theta. And like earlier, we know that it's not accelerating this direction or this direction, so Fn will be equivalent to mg cosine theta. This will cancel. And then what is the only force remaining? It's this one. And what you need is the F net, right? So your F net is only equivalent to this one, which is mg sine of theta. Your m is 2 kilograms. Your g is 9.8 meters per second squared. Sine of 14.48. You should be getting a net force of 4.9 newtons. Alright, that's it.